Your AI tools can handle simple requests, but what about complex, multi-step conversations that need to maintain context? We'll build a FastMCP tool that simulates a natural back-and-forth analysis session where the AI first acknowledges the data, then asks for clarification, and finally delivers targeted insights, all while keeping the conversation history intact. You'll see how structured message passing makes multi-turn interactions feel seamless. From FastMCP client sampling, import SamplingMessage. At MCP, tool. Async def multi-turn analysis, user query. SDR context data, SDR CTX, context, SDR. Perform analysis, using multi-turn conversation structure. Messages equals. Sampling message role equals user. Content equals F I have this data. Context data. Sampling message role equals assistant. Content equals I can see your data. What would you like me to analyze? Sampling message role equals user. Content equals user query. Response equals await CTX. Sample. Messages equals messages. System prompt equals you are a data analyst. Provide detailed insights based on the conversation context. Temperature equals 0, 3. Return response text. This demonstrates the multi-turn conversation pattern for LLM interactions, where a single API call simulates a complete dialogue history. The technique constructs a structured message sequence that mimics natural conversation flow, allowing the LLM to process context and queries as if they occurred in real time. What makes this distinctive is its ability to encapsulate complex interaction logic within a single tool call, while maintaining the conversational state implicitly through message ordering. The pattern works by leveraging the LLM's native context window as a state container, where each message in the sequence builds upon previous ones. By structuring inputs as alternating user assistant turns, you create a self-contained interaction that requires no external state management. The framework handles the message serialization and LLM communication, while your tool remains a simple pure function that composes the conversation structure declaratively. This approach solves the problem of stateless tool design in conversational systems, where you need to maintain dialogue context without persistent storage. It's particularly valuable for analysis tools that require setup steps or contextual priming before handling the main query. The trade-off is increased token usage for the full message history, but the benefit is complete encapsulation of the interaction logic within a single callable endpoint. Let's break it down line by line. From FastMCP client sampling, import SamplingMessage. This imports SamplingMessage, FastMCP's structured message format for multi-turn conversations. It enforces consistent role content pairs, ensuring the AI receives properly formatted conversation history. At MCP, tool. Async def multi-turn analysis, user query. SDR context data, SDR CTX, context, SDR. Perform analysis, using multi-turn conversation structure. This defines an AI callable tool using FastMCP's decorator pattern. The @MCP tool decorator exposes this async function to AI models, while the type hints and docstring automatically generate the tool's schema. The context parameter enables logging and progress reporting, required for all FastMCP tools. Messages equals. This initializes the conversation history as a list of sampling message objects. The multi-turn structure preserves context between user and assistant interactions, enabling stateful analysis across multiple exchanges. This pattern mirrors how chat interfaces maintain dialogue continuity. Sampling message role equals user. Content equals F I have this data. Context data. This initializes the conversation history with the user's data context. It establishes the foundational information the AI needs before processing the actual query, ensuring the analysis operates on complete context rather than isolated questions. This follows the multi-turn conversation pattern where prior messages shape subsequent responses. Sampling message role equals assistant. Content equals I can see your data. What would you like me to analyze? This injects an assistant response into the conversation history, simulating the first turn of a multi-turn interaction. It establishes context by acknowledging the user's data before prompting for specific analysis needs, which guides the model's subsequent reasoning. This pattern ensures the AI maintains conversational flow rather than treating each query in isolation. Sampling message role equals user. Content equals user query. This final sampling message injects the user's actual query into the conversation history. It completes the multi-turn structure by providing the specific analysis request while maintaining full context from previous messages. The pattern ensures the AI receives both the data context and the precise question in a single coherent conversation flow. This closes the messages list definition. It finalizes the conversation history structure before passing it to the sampling function, ensuring all role content pairs are properly contained. Response equals await CTX. Sample. This triggers the sampling operation, sending the conversation history to the AI model for processing. The await handles the async response, ensuring non-blocking execution while waiting for the model's output. All FastMCP tools use this pattern for AI interactions, where CTX, sample, manages the request lifecycle and returns the structured response. Messages equals messages. This passes the conversation history as a list of sampling message objects. FastMCP uses this structured message history to maintain context across multi-turn interactions, enabling stateful conversations with the AI model. System prompt equals, you are a data analyst. Provide detailed insights based on the conversation context. This defines the system prompt that sets the AI's role and behavior. It ensures the model responds as a data analyst, not a generic assistant, and forces it to use the conversation context for detailed insights rather than generic answers. The low temperature setting, 0.3, combined with this prompt creates deterministic, focused analysis responses. Temperature equals 0.3. The temperature parameter controls response randomness in the sampling process. Setting it to 0.3 produces focused, deterministic outputs while maintaining some flexibility, ideal for analytical tasks where consistency matters more than creativity. This prevents overly verbose or tangential responses in data analysis contexts. This closing parenthesis terminates the CTX, sample, call, finalizing the asynchronous request to the FastMCP server. It ensures all parameters, messages, system prompt, and temperature are properly passed before awaiting the response. Without this, the function would remain incomplete, preventing execution. Return response text. This extracts the generated text from the sampling response object, returning only the AI's analysis as a clean string. The pattern ensures tools return raw content without metadata, matching FastMCP's expected string output contract. Multi-turn analysis pattern. This implementation demonstrates FastMCP's conversation-aware sampling, where context accumulates across message turns while maintaining strict type safety through the context object. The temperature parameter directly influences creativity versus determinism in responses, with 0.3 favoring focused, analytical outputs. Always validate message content types before processing, as sampling message content may be text content, image content, or other variants.
The conversation that remembers everything must first forget how to speak.